By the late 1800s, there was a Russian chemistry teacher by the name of Dmitry Mendeleev who wanted to create a way to help his students memorize the properties of the elements. So by this time, there were about 60 different chemical elements that had been discovered, and chemists at the time just had to simply memorize their melting point, their boiling point, their density, their tendency to form compounds, their reactivity. It all had to be memorized. And so Mendeleev wanted to create a way for his students to learn these without simply memorizing them. What Mendeleev did is he took each element and he wrote an index card for it. And on the index card, he would write all the different properties for that element. And then he started rearranging and organizing all of the different element cards until he could recognize certain patterns. What Mendeleev noticed was the properties of the elements had a periodic fashion. Now, the word periodic means that it occurs in regular intervals. So often in the mail, you might receive a periodical, which you would probably call a magazine. And that periodical might arrive in your mailbox once every 2 weeks, or maybe once a month, but it arrives at regular intervals. The same thing is true with the elements on Mendeleev's cards. When he arranged them by atomic mass, there was these reoccurring properties that seemed to appear. So then what he did is he grouped the elements horizontally by these properties. So if you're looking at his periodic table, here with lithium, sodium, potassium, rubidium, and cesium, they were all in the same horizontal row, so they all had similar properties. Same thing with fluorine, chlorine, bromine, iodine, all in the same horizontal row, therefore all with similar properties. As he made his periodic table, he left several blank spaces where he didn't have elements that would quite fit, and he proposed that those elements just hadn't been discovered yet. And what made Mendeleev's table so great was that even though he designed this table in 1869, those places that he had left empty, the elements were actually discovered by 1886. And so the discovery of those elements showed the strong predictive nature of Mendeleev's table. The only problem with his table is that most of the elements fit in this arrangement by atomic mass, but not all of them. There were some elements that seemed out of place. For example, iodine has a mass of 127, but in order to make it fit with bromine and chlorine and fluorine, which it all has similar properties to, he had to put it out of order, and he had to put tellurium above it with 128, and then 127. And he knew that that seemed off, but that's where it fit best in his table. It wasn't until about 50 years later that a student named Henry Moseley figured out a better solution. He was actually a graduate student of Ernest Rutherford. He was doing a lot of investigation and research into the charges of the nucleus of each atom, and he found that the periodic properties of the elements fit better when they were organized by atomic number rather than by atomic mass. So he rearranged the table and revised Mendeleev's law. Our new periodic law says that the properties of the elements are a periodic function of their atomic numbers. And this is the basis of the periodic table that we use today. And so if you look at a periodic table, we start in the top left-hand corner with the number 1. That's the number of protons, right? The atomic number. And then we slide over to helium, who has an atomic number of 2, or 2 protons. And then the row underneath it goes 3, 4, 5, 6, 7, and so on, all the way down until we get to element 114 at the bottom of the table. So the modern periodic table, the one that we use today in class, is arranged in order by atomic number so that the elements with similar properties are in the same group. Now remember that groups are vertically arranged, so we've also rotated the arrangement of the table. Mendeleev's elements that have similar properties were in horizontal rows, whereas our modern periodic table, elements with similar properties are in vertical columns called groups. There's been some major additions since Mendeleev made his first periodic table. In the 1890s, the noble gases were discovered, and so on the modern periodic table, they are listed as group 18. In the early 1900s came the discovery of the rare earth elements, also called the lanthanides, and those are placed as period 6 on our modern periodic table. And then in the 1940s and 1950s, there was a lot of research being done with radioactivity. They were able to synthetically create many new radioactive elements that are part of the actinide series, and that is period 7 on the periodic table. Now remember that period 6 and period 7 on the periodic table are actually placed below the periodic table in order to conserve space. Because if we didn't do that, then the periodic table would be very wide and wouldn't easily fit into textbooks and other reference material.